Okay, let's calculate the limit as x goes to 0 plus x to the x power. So, as you can see, when we plug in 0 into this x and that x, we get 0 to the 0 power. In that case, in fact, we cannot draw any conclusion because 0 to the 0 power in the limit situation is one of the indeterminate form. That means we have to do more work, alright? We cannot draw any conclusion at the moment. And here is what we can do. As you can see, the trouble is we have a function raised to a function power x and then raised to the x, right? This is what we can do, just like how you would like to differentiate a function to a function power. So, in fact, I did this with you guys already, how to differentiate x to the x power, right? What we can do is look at the base, which is x now, and the problem is that's a function. Ideally speaking, I want to write this in terms of e to the something, so that I can have a constant for the base, right? So notice, let me just put this down right here. Right here, x can be written as the following. I really want to have the e to work with. Why e? Because e to the something is the easiest to differentiate, right? Well, e to what power will give us x? Remember, e is the exponential function, and we have to remember its inverse, which is ln x, right? So if I put ln x, then you see e and ln will cancel, we get the x back. Now, I'm just going to replace this with that x right here. So that way, I can work with the base e. And let's go ahead and write this down, the limit as x goes to 0 plus. This is that, namely e to the ln x, and then take this raised to this x power, like that. And then we have a situation, a power to a power. What should we do with the powers? Multiply them, isn't it? Now, I'm just going to write this down again. Take the limit as x goes to 0 plus. The base is still e, and then we have x in black times this, ln x in red, right? And now what? If we plug in 0 plus into this x and that x now, let me just show you guys this real quick. 0 plus in here, we have 0 plus times 0 plus into ln of 0 plus. Okay, this is just 0 plus times ln of 0 plus. Remember the graph of ln, which looks like this, right? When x is approaching to 0 from the right-hand side, namely if you're coming from here, you see that the graph is going down, right? It's going straight down. That means ln of 0 plus is approaching to negative infinity. Here, when we have 0 times negative infinity, this is also an indeterminate form. That's no good as well. So, what can we do though? And by the way, you see, here we have e to the something. When we take the limit of e to the something, because e to the something is a continuous function, this is what we can do. Let me write this down for you guys. This is in fact the same as the following. We can take the limit to the x times ln x first, and then do e to that power, alright? Once again, we can do that. It's because e to the something is a continuous function. So let me write this down for you guys. Let me just put down, let's have the e first, and then have the limit right here. Let's focus on taking the limit as x goes to 0 plus x times ln x right here, alright? And this is the exponent now. As long as I can figure out what this is, hopefully it's a nice number, so then I can just do e to that nice number, and that will be the final answer. Well, as we talk about it, x times ln x, when x is approaching to 0 plus, we have an indeterminate form. This is 0 times infinity situation, right, technically. This is what we will like. This is what we don't like, because we cannot use L'Hopital's rule. We like L'Hopital's rule, right? Under two conditions, we can use L'Hopital's rule. First is 0 over 0. Second is infinity over infinity. So this x will produce a 0. What we can do is we can bring this x down, so that it becomes 1 over 0 plus, namely that will become infinity in the denominator. And let me show you. So now, let me just write this down again. This is going to be equal to the following. So let me make sure the equal sign is still in the picture, like this. Okay, we have e is still e, the limit. So let's still write down the limit, just to be legitimate. And now, here this is the x. What we are going to do is, let's keep the ln x on the top, right? Here. And then I'll bring that down. The x is the same as saying 1 over x, all right? And as you can see, yes, I produce a complex fraction, but of course, if you multiply x here and x here, this x and that x will cancel out, so we get back to x times ln x, and that's still the same as the original. And with this being done, when I plug in 0 plus onto the top, we have ln 0 plus over 1 over 0 plus, right? On the top, this right here gives us negative infinity. On the bottom, this gives us positive infinity. Well, I still don't know what this is, but I know I can use L'Hopital's rule now, right? So let's go ahead and do that. L'Hopital's rule says we will just differentiate the top, and we'll also differentiate the bottom. And the reason that I want to bring the x down is because it's much easier to differentiate. You could have brought the ln x down as well, and good luck with differentiation in that case. But anyway, let's see what do we have from here. E is still e. This is still in the power, right? Let's go ahead and still put down the limit as x goes to 0 plus. On the top, the derivative of ln x is just 1 over x. On the bottom, the derivative of 1 over x is negative 1 over x squared. And the whole limit right here is still in the exponent. And now, this is a complex fraction, 1 over x over negative 1 over x squared. What can we do? Well, we can just multiply the top and bottom by the lowest common denominator of the small fraction, namely x squared, and you will see this right here will give us the following. E is still e. We still take the limit as x approaching to 0 plus. I know we have to write this down a few times, but just to be legitimate, all right? And just have some patience. Anyway, 1 over x times x squared, we get x on the top over this right here, x squared and x squared cancel out. Of course, we have negative 1. And now, we can happily bring the 0 plus into this x. And we get what? This is going to give us e, and then plugging 0 into here. 0 over negative 1 is 0, right? And at the end, you see, this 0 is from this limit. But don't forget still to do e to that power. At the end, the answer to this is 1. E to the 0 power is 1, all right? So in this case, let me just write that down right here again. When we take the limit as x goes to 0 plus x to the x power, this right here is equal to 1. And this right here is how you are going to show it to be legitimate, all the work, all the steps behind it to show legitimately that this is equal to 1. Do not just put down 0 to a 0, it's equal to 1, all right? But it just happened to be 1 as well, with all this work to support this answer. Anyway, that's it.
So good.